My teachable students, I welcome you to our special class where we present the simplicity of the science subject. Today, I'll be teaching us a topic in physics, and the topic is motion. So I'll be explaining everything under motion. Then that will take us to type of motion, and I will explain everything that we have under the type of motion, all right, with enough practical examples. So that will take us to what causes motion, the agent that causes motion. So after talking about that one, they will now move to the types of that agent. All right. So explaining everything in details. Then that will not take us to, I think, calculation aspect, okay, under motion and the agent that causes motion. And all of this will be explained in detail. What I need from you is your attention. Make sure you have writing material and write every necessary thing that needed to be written down. All right. So your understanding is blessed as you listen. So let's start with explaining what motion is. Motion is change in position of an object with respect to time. Let me explain. When we say change in position, we mean when an object moves from one place to another. Okay, so once an object moves from one place to another with respect to time, we say the object has undergone change in position, and we term that as what? As motion. All right. So look at this place. Look at this car. It's moving from here to there. So from this place to that place means change in position. Of course, it's done with respect to time. So we say that object has undergone motion. Okay, change in position from one place to another, from Abeokuta to Ikeja, from Abeokuta to Ibadan, or from Ogun State to Lagos State, or from Ogun State to Oyo State. All right. So once an object moves from one place to another, we say such object has undergone change in position, which we term as what? Motion. Of course, with respect to time. Motion can exist in solids, it can exist in liquids, and it can exist in gases. Let me explain each of these. When it comes to motion in solid, we talk about a car or an object moving from one place to another place. Okay, that is motion in solid. Now, when it comes to motion in liquids, all right, a good example is a river. Now, river always move downhill. River always move downhill. That is a good example for motion in liquids. So when it comes to motion in gas or gases, we talk about particles or smoke suspended in air, moving randomly without a specific direction. We can term that as Brownian motion. All right, so these are the example under motion in solid, liquid, and in gases. So let's go to types of motion. All right, I think we have maybe 4 or 5 type of motion. Let me start this way. The first one as translational motion. Now, translational motion is when an object moves from one place to another place in a particular direction, in a fixed direction. That is translational motion, of course, with respect to time. Right? So when object move from one place to another place, okay, in a particular direction, we'll term that as what? Translational motion, of course, with respect to time. Look at this car again. The car move from here directly to there, from this place directly to that place, okay, with respect to time. We term that as what? Translational motion. Now let's talk about oscillatory motion. Now when it comes to oscillatory motion, this is a to and fro type of motion. To and fro type of motion about a fixed point. about a fixed point. Look at it here. This is the fixed point and this is the object. It's going from left to right and back to left to right and back to left. Okay, and it continues like that, all right, until friction act on it and it stop eventually. So to be explained later. Now, going to fro is it also form a path, okay, through which the object go to fro. So the object cannot go below the path or above the path. So to maintain that path as long as it is fixed to this point, all right. So under oscillatory motion, the path formed physically is not a complete circumference, all right, even though it can be explained that circumference exists there, all right, but physically what you have is not a complete circumference. It's from left to right and back to right. Okay, so that is what oscillatory motion, all right. Example of that, you can get that online or get textbook and search for examples under what oscillatory motion. Now the third one that look like it is rotational motion. Rotational motion, all right. Now when it comes to rotational motion, all right, the object turns. So it turns about a fixed axis. Now, why axis, not point? Okay, because there's a rod. So it's that rod that holds the object, and the object is rotating about that rod. Do you understand? Like, look at this now. So what I did there, see, this thing is rotating about this rod. So we call this axis. Do you understand? It's axis. Now, we're talking about, if you look at what I hold now, the edge form circumference, in fact a complete circumference, unlike the oscillatory motion that I said physically what you have is not a complete circumference. The edge form a path and we can call that arc. It form an arc, all right. But under rotational motion, the edge now is forming a complete circumference, all right. So and that edge, it can go beyond the path of that circumference or below the edge of or below the path of that circumference, all right. So to maintain that part of that circumference as long as the body is fixed to the axis, all right. So under rotational motion, the object turns about a fixed axis, all right. Is that clear? Though the edge undergo what we call circular motion. Of course, circular motion is an example under rotational motion, but when it comes to explaining them in detail, circular motion is a bit separated from rotational motion, all right. But they are very related. They are very related. Okay, even oscillatory motion is connected to rotational and circular motion. Is that clear? Then the next one is the random motion. Okay, random motion. This is when an object moves without a particular direction. All right. We talk about smokes suspended in air or particle. Okay, suspended in air. So they just move randomly. All right, randomly. Of course, there's a change in position. They move from one place to another place, but without a particular direction.
The movement of the thermocol balls is random motion. Random motion is a motion without any definite sequence or direction.
All right, so we term that as what? Random motion. All right, and the last one, okay, is the relative motion. Relative motion. Let me explain that a bit. All right, so if you are in a car, all right, and the car is moving with a speed, and you look at nearby trees or poles on the road, all right, you look as if the trees and the poles are also moving, all right. So it means you and the trees that seems to be moving, you are both in relative motion. Even the car with the trees and the poles are in relative motion.
Have you ever sat in a train and while staring out the window, you notice another train on the other platform? And then you start to see that other train moving away. And you start wondering, I wonder where that train is heading to. But a few moments later, you discover that train isn't heading anywhere. It's not that other train that's moving, it's you that's moving. And so, although the other train appeared to move, you were the one that actually moving away from the platform. Seems weird, right? That is a concept called relative motion.
Okay, but if you have, maybe you are two or more in the car, I will term you as passengers. So those passengers are in relative motion with respect to the trees and the poles, okay, on the roadside, but at rest with one another. The passengers are at rest with one another. Did you understand that now? Okay, the next thing is what causes motion. All right, so the only or the primary source, okay, that causes motion is force. All right, so force is an agent that brings about change in position of an object, of course with respect to time. All right, so force is the agent or the primary source that bring about change in position of an object with respect to time. All right, so now let's talk about types of forces. All right, so there are two major types of forces. Number one, we have the contact force, and number two, we have the field force, which you call non-contact force. Let me start with the first one. When it comes to contact force, we are talking about a situation whereby the force is in contact with the object is acting on. The force is directly in contact with the object is acting on. All right, so examples, or let me say, contact force can be divided into three. The first one is like force, the second one is unlike force, the third one is frictional, or you say viscous force. Let me explain the three. When it comes to like force talks about push. Okay, if you are to push an object, you may be three or four in number, you all be pushing it in one direction. That is like force, in one direction, like force. The second one is unlike force. Let me explain that this way. If I'm pulling you and you are pulling me, all right, I'm on this side, I'm pulling you, you are on the other side and you are pulling me, so it means the forces are in opposite direction, so we call that unlike force. There's a contact. Okay, we may hold our hands, I'm pulling you, you are pulling me, pulling you, pulling me, there's a contact. Do you understand? And the third one is the frictional force. Okay, of course this one oppose motion or slow down the speed of an object. That will be explained later. So let's go to the second type of force, which we say force field or non-contact force. Now this is a situation whereby the force is not in direct contact with the object is acting on. All right, so it is the effect of that force that move the object. Do you understand? So the object will be in a region of influence, physical influence, and the influence will move the object. Do you understand? And the non-contact force is also divided into three. We have the magnetic force, we have the gravitational force, then we have the electric force. All right, so all this deal with region of influence. So if an object find itself in that region of influence, it will cause that object to change position, to react. Did you understand that? All right, so these are the types of forces. All right, so now we are going to calculation aspect. All right, so before the calculation aspect, I want to ask you, did you understand all I've explained from the beginning? Okay, from motion to where we stop now. I will say meet us in our next video to see how we solve the problems we have under forces. All right, so have it in mind that there's nothing difficult about science subject. From DFM Mike Matthews, I say thank you and bye for now.